So in this video now, we're going to be proposing the synthesis of this molecule. NC, that's a ketone, and 1, 2, 3, 4, 5. So that is 2, that's carbon 2, pentanone. So I'm going to find a couple of ways to make this compound from smaller molecules. So one path that I'm going to now go over with is this. I'm going to disconnect right there. And that will leave me, I'm going to do it again, two fragments. These fragments are, I'm going to do on one end acetyl chloride, and on the other end, I'm going to have propyl bromide, with the idea of making this a Grignard reagent. And so if I didn't have acetyl chloride, I can make it from acetic acid and make it react with thionyl chloride. Thionyl chloride, I make acetic acid. And to make this to react, I need to make a Grignard reagent. So here I'm gonna add magnesium, and I'm gonna do this in dry ether. And I'm gonna get my metal, I need one more carbon, 1, 2, 3, 1, 2, 3, metal magnesium bromide. And now I have my nucleophile to attack here. Remember that reactions with carboxylic acid derivatives are essentially nucleophilic acid substitutions. So here, with this attack with the Grignard, you're going to make the following alkoxide. And we will be, now, this is your chlorine, that's the metal group. And now I have 1, 2, 3. 1, 2, and 3. We're going to reform the carbonyl, and that's going to push the chlorine out. So the final product will be what I have here. So notice that chlorine departs. And now I have formed a ketone with that you can call, say, metal propyl ketone, and also butanol. So that's one path that I can visualize. Let's do it another way. So now I can propose that this ketone coming from an alcohol. I know I can make ketones from secondary alcohols. I'm going to redraw it because it came out too high. That's a secondary alcohol. So what do I need to do to go from the secondary alcohol to the ketone? Well, here I need an oxidizing reagent. Typically, we will use John's. Here, John's is my oxidizing agent. This is chromic acid. And we make it two ways. The reagent is done either by using sodium dichromate and sulfuric acid, or we can use chromium trioxide and sulfuric acid. Either these two ways. So that's my oxidation reaction. I'm going to keep disconnecting this since I need to go and find the smaller molecules. So I can think of the alcohol coming from the hydration of an alkene. So it's this one. So now from here to here, I will need to do a hydration reaction. Of course, I will have probably to separate the mix. I will have an alcohol in this position and in this position at this point. Now, once I have, again, going backwards, from the alkene, I hydrate, get the alcohol, and then I oxidize the alcohol, get the ketone. Now, how do I make the alkene? Well, here we're going to disconnect again. And when I do that, this can come from Wittig reactions, two possible ways. Because when we do Wittig, we can put the carbonyl compound on either end. So one possible way would be having, this is propanol, and we will have So ethyl bromide, but this ethyl bromide, propyl bromide, I need to react with triphenylphosphine to these to make my elite, followed by N-butyllithium. So that way, with all of these, I'll be making my elite. All of these is to make my elite. My elite will be now having a double bond here with triphenyl. No, let's do the phosphorus directly attached. So I'm gonna have that double bond PH3, and then 1, 2, 3 carbons. The goal is then when you have you make your elite, now you're combining these two, and you will be inserting all of these in place of the O. That's so in disconnecting the alkene, that's one way. The other way will be having the oxygen on the other end. So another possible disconnection, that's one approach. The other approach is having ethanol. So these was propanol, and here you have here I have an extra carbon, 1, 2. I needed only 2 carbons in this fragment, so I'm gonna erase one of those because it's ethyl bromide. So 2 carbons only. All right. So the other fragment then could be I put the oxygen here, so that'll be ethanol. And with the other fragment, I make the elite. So the other fragment gotta have 3 carbons. So I'm gonna have 3 carbons in the bromine. And again, strategy here is use the alkyl bromide to do a Wittig. So I'm gonna have this react with triphenylphosphine. And again, we have more videos about explaining how you make elites. Essentially, it's into reaction. And then we do an acid-base reaction. So you need triphenylphosphine and you need N-butyllithium to make the elite. The elite in this case is going to have the following structure. After you treat it with butyllithium, this is formal positive, this you have electrons, and you will make a compound. I'm going to write it on the other end, so it's going to have 1, 2, and 3. Now I'm going to have this. And again, Wittig strategy, once you make the elite, is to insert all of these where in place of the O, like I did here. So a couple of ways that you can disconnect that and use the Wittig reaction. So here in summary, we have found 3 synthesis strategy. One involves a Grignard reaction over a acyl chloride. And now analyzing here, if I had acetyl chloride available and didn't have to synthesize, essentially, we just need to make the Grignard reagent, and this is only 3 carbons that I'm using. And essentially, almost one step. Once you get the substitution, the attack, you get the substitution. The only problem with this is that Grignard, you need to control that because Grignard is capable of attacking the ketone. So, of course, you can work with, say, the stoichiometry. But a better way to do this is actually not using Grignard, so another bad way. So Grignard is not that good again because you can have Grignards can attack here. And then you will not get your product. So if I did that, let's say here R negative, and you know that the R is all that. So problem with this pathway is that I can have another attack, and that would lead to the formation, if that happened. And again, controlling the stereochemistry can help, but that will also form, let's erase that, a tertiary alcohol. You don't want this to happen because that's your target. So we don't want this. So what can we do? So similar to this pathway, we can use Gilman instead. So Gilman region is another organometallic, and here you will do, say, R2CuLi. So copper, you will have to, in this case, I need propyl. So I'm going to say propyl, 2 of those, copper in Gilman. The advantage of using Gilman is that Gilman reacts with acid chloride, which is what I want here. So you will do the propyl again by coming from the Gilman, attacking over the acid chloride. But the advantage of using Gilman instead of the Grignard is that Gilman cannot attack ketones. So summarizing them, we have 3 pathways. The Grignard has an issue that it will be easy, but you can work with the stoichiometry. However, you can have the attack of a second molecule of the Grignard region over to the ketone and produce a tertiary alcohol, which is something you don't want. To avoid that, we have then explained that we would use Gilman instead, because Gilman will do the attack over to the acid chloride and produce, this is what you are adding, produce this intermediate and then go to the ketone. The ketone will not be attacked by the Gilman, so it stays there. The other pathway is what we explained, involves 2 different paths, disconnection paths using Wittig reagents.